Hello, everybody. Welcome to another episode of DevOps Decrypted. I'm your host, Romy Greenfield, and today joining me, we have some new guests as well as some similar faces. So we have Rasmus, we have Michael, Timothy, and Daniel. Do you all want to take it in turns to introduce yourself? Michael, if you want to go first.
Yeah, so I'm Michael. I'm a co-founder and CTO of a company based out of New York City called Plural.sh. And what we do primarily is making it very easy for people to deploy a large variety of open source software onto Kubernetes into their own cloud environments. So we've spent a lot of time playing around with Kubernetes, and all three of the big three clouds have a fair amount of knowledge to share there, and hopefully can contribute to the conversation.
Awesome, thank you. Timothy, do you want to go next?
Hi, Timothy here. Current job title is a team lead or platform team lead at Venue DevOps, which is part of Adaptavist group. So we are building a developer experience platform here in Venue DevOps. So yeah.
Thank you. Welcome. And Daniel.
I'm Dan. I'm an engineering manager for an infrastructure team that works inside business services. You could say we're like a platform team, but generally we do a bit of everything.
Awesome. Thanks for joining us today. So today, I think we're going to talk a little bit about Kubernetes and it actually being quite hard. Does anyone want to kick off the conversation?
Sure. So I can chip in since I threw the topic out there, because nowadays I think we're past the point where people have recognized that, oh wait, yeah, Kubernetes is actually still hard. Just using it raw and looking at the gigantic, cloud native computing foundation map of, hundreds of different things you can do with Kubernetes, it's gotten pretty crazy. It seems kind of like it hasn't really gotten easier to use it, yet there have been a lot of attempts to do different layers at top of Kubernetes to make it easier. So what have we done? What have others done? What are we even trying to do? What are you trying to orchestrate? Are you trying to just do better workflow management or workload management? Are you trying to make the developer experience easier? There's so much to go on. With Adaptavist, we've tried a bunch of different things, which is why I invited Dan, aka Chalky, here on the call to sort of just give us a little intro on, hey, what have we done with internally at Adaptavist over time?
We've done quite a few things. We haven't actually got anything that I'd say looks like a platform yet. Is one thing I'd be honest about. I think I've seen over the years, we've all seen people go across this digital transformation journey. I'm doing air quotes here. That takes years and then nothing's delivered because actually it's hard to deliver a platform for people. And that's what Kubernetes is, but it's not a platform. It's a framework, really, as far as I'm concerned. It gives you the foundations to build some things, and actually the most important part of the journey isn't actually Kubernetes. It's actually about what is the finished viable platform for your organization. And actually that question is different depending on the size of your business, how many business units you have, what does good look like. That answer will change depending on who you ask. And so part of our earlier journey was product pods. It's Adaptavist equivalent to Plural. You could look at it that way. It is a service catalog. You can run a turnkey application on it. It's just that the turnkey applications are purely Atlassian focused. We want to run things like Jira DC and those sorts of things on there. And so that's the first part of it. Yes, and still is.
Sure.
And still is. And Plural might actually be a suitable replacement for it, because one of the problems of Rancher is end users are scared of it somewhat. So you've got this nice little service catalog. It's really cool, but actually it's a bit of a power user tool when you go into it. Like there's a lot of knobs and dials to change and stuff. And yeah, and some of these people they're not developers, they're not SREs, they're not DevOpsy people, they're consultants. They know how to manage Jira, and they just see all these options and they don't know what to do. They just have to follow some guide and hope for the best. And
it's really still just a UI for Kubernetes, much like you would see like a nice dashboard on VKE.
Underneath, it's just a chart. It's just a rancher flavor of a Helm chart. And ultimately you can abstract that any way you wanted to. It's just that for the sake of getting something done quickly, we picked Rancher. Also, because it did cover some other use cases, by the way, so things like SAML, like SSO, that kind of stuff. It answered some of those things out of the box. So it was like the path of least resistance was to pick that tool, but the sacrifice was the user experience. And over time, we'll correct that. And again, this goes back to the finished viable platform. Like, what's the correct thing at this point in time? And in the future, you keep iterating.
Yep. And I do also remember that we did start a backstage at Adaptavist as well. But much like you said, Kubernetes is a platform, but it's really kind of like a framework to build a platform. Backstage is almost like, yeah, it's an IDP, but it's almost more like a framework for building an IDP. You really have to dress it up yourself a lot.
Eventually, it will be a framework, is how I'd answer that. It's still in that phase of not being in an internal project at a company anymore, and so it's having to change its shape to accommodate the fact the community runs it now. So it doesn't have things like a robust plugin system. It's still got some of the technical debt of it being internal, where you just change some boilerplate and things happen. It's not bad. It's just an evolution of it being open sourced. And eventually those things will become mature. So until then, I wouldn't necessarily even call it a framework. Not yet. It's not in the right shape to be a framework, but it's still a powerful tool, right? You still get some good stuff out of the box.
They are weirdly similar in a sense. Kubernetes also came out of Google and became open sourced and adapted and adopted and worked on and so on. Even though you might still have a hard time asking somebody, hey, what does Kubernetes do?
Well, it could do anything. It could do anything if you so wish it to, or have the intelligence to do it yourself. It's in simplest terms, it's an orchestrator, right? It doesn't even necessarily have to be containers if you know what you're doing. We talk about Crossplane, a perfect example of that, right? It's not containers we're orchestrating now. We've just given it a different DSL to run and do infrastructure.
Yeah. Real quick on that, then, internally we have been playing with something that you call Kubera, that also uses Crossplane and so on. Can you tell us a little bit about how that works and what does it do?
Yeah, so Kubera it's more of a code name internally for the question is, what does a Kubernetes look like at Adaptavist and its numerous business units? So it's more of a discovery for us. Again, talking minimum viable platform. And so for that, we're kind of eating our own dog food, because we write our own services and stuff, and we need to run them somewhere. And everyone's got a slightly different, approach to doing it. And actually, teams in Adaptavist, we have the same problem, right? We have different business units, teams. They've made their own platforms because there hasn't one that pre-exists. And so we're just trying to work out what's the finished viable one that we could give people options. And we want to start with the developer experience. That's about feedback. So it's not about giving them a production environment. It's not about telling everyone they need to move to this. Things about, can we improve their feedback cycles? Can they get feedback faster as part of the development life cycle? And it's those sort of things we care about more. So that's where we've started off looking at things like Argo CD. We've started looking at remote developer environments. So how quickly we can get them the environment set up and running. And we look at things like telepresence and such as well, so they can actually run a container, get feedback from it, but it's still integrating with adjacent services and stuff. But simply, Kubera is actually just about us doing that discovery and working out what that finished viable platform is. But we also know that there is some baseline knowledge that we have to acquire in the team first before we can even go out further and look at all these other add-ons, services, and products.
All right. And that's getting me excited to talk about Plural. But let me get through one little quick thing first. I know Plural does some of those things, but you also had worked with Crossplane. And I know Tim has been working with Crossplane because we're working on the whole venue thing together. What are our thoughts on Crossplane? I mean, how are you using it correctly? How does that orchestrate Kubernetes?
Well, honestly, I don't even know what using it correctly looks like yet, is my first answer. I know what using Terraform correctly looks like, and maybe I'll work backwards from that. So the first thing we did when we installed Crossplane was seeing the numerous amount of CRDs that they just drag the control plane to, not to a halt, but might as well be. And so what we did is that we went, okay, let's just focus on the one CRD we care about, and that is the Terraform module, because we've got loads of modules we already use. And if we can just provide a suitable abstraction for that, I think we'd be happy. We're cooking on gas, rather than re-implementing the same thing, but under a different DSL. And that was our way of controlling the load on the Crossplane, on the control plane, because that control plane only has one CRD now, or that's the one CRD we care about. We don't care about all the others because we'll let Terraform do the rest for us. And that's kind of how we've managed it for now. But we've not had any real big gotchas, really. Other than that, it's just us learning to read the manual half the time, actually, than understanding the product. But we've not used it in anger enough to have any of the painful lessons yet. The only nice thing about sticking to the Terraform module provider for it is it means I can use my current domain knowledge to at least triage the problem, because then that knowledge goes back to the module to Terraform, not to say the Kubernetes or Crossplane itself. I've shifted the problem. Essentially, I've managed to complete the cognitive load of the complexity on the team by choosing something that could be seen as lesser, but it's again like right choice at the right point of time, and then we might change our minds as we go forward.
So that brings me to sort of the next step of Crossplane and Terraform. Do you use them together? Can you use just one or the other? I know Plural just uses Terraform, but we also are trying to use Crossplane for Venue. Tim, what are your thoughts on the whole setup?
So yeah, just like Daniel, Chalky has mentioned that Crossplane does have different providers for example, for AWS, different of the clouds, and even for Terraform. So I've tried to use Crossplane with the Terraform provider, and one thing that I learned, my lesson from that, is to make sure that the Terraforms that you pass into Crossplane is a manageable size Terraform, right? In a sense that don't throw in a Terraform that runs for like 20-30 minutes, because you won't get much output from the Terraform provider in Crossplane. So that's one of the main things that I learned from that. Otherwise, it's just re-implementing Terraform in another wrapper, just like yeah.
So that brings up a thought, because this is really technical and awesome and all that, but pretend for a moment I'm a dumb user, because I am. If I'm looking at Kubernetes and Terraform and Crossplane and all these things, ultimately I want to host things on there. So what are we actually trying to do by introducing Crossplane instead of or in addition to Terraform? Terraform is about multi-cloud. Crossplane is about multi-cluster. What are we talking about here, really?
So the Terraform thing is just to manage our cognitive load. There's other things we're trying to learn, and we're trying to not put too much weight on the control plane. That's why we've opted to use Terraform in that way. To the end user, there should be a suitable enough abstraction that they not that they don't care, but they should care less or worry about it less. So I don't know, think of using something like Kubevilla, and now you're introducing annotations to decorate your charts, and all that person's now saying is I want a database. Actually what actually is getting pulled in is hidden from them, essentially, or to a degree hidden from them.
I think what the user wants is a nice and friendly user experience, right?
Yeah.
What they want is a site that shows up, which is friendly, has good UX and good UI, and shows them the infrastructure that they want to build. Correct. So Crossplane does facilitate the back side of that, right? It abstracts for the developers that develop the platform. It helps us abstract those information and only capture the information that they need, or which is, for example, you want a database? Okay, do you want a Postgres or MySQL or MS SQL, right? And that's it. So yeah, I think that's what the user wants, and Crossplane does help to do that in the backend, but there still needs to be something for the user to use.
It almost sounds like there should be a front end, like something like Plural, that makes it all nice and neat. Maybe we should talk about that for a little bit.
Yeah, so I'll speak to Crossplane specifically and then go into what we're doing. So we have used Crossplane at Plural a few times, and the issue you mentioned about it jamming up the control plane, we hit pretty quickly. And I don't know how deep you guys dug into it, but it's basically it's a bug in Kubernetes itself that gets triggered. So when you add a CRD to a control plane, there's a process in the Kubernetes control plane that basically reconstructs the entire Open API specification for the Kubernetes control plane on each CRD load. And that's an extremely heavy process. And then on the other side, when the Kubernetes client runs any, when it like the Go client specifically runs any API call, it'll do a discovery call against that Open API spec to do some like basic pattern matching in case you don't provide the fully specified like API. And so if you put in a few hundred CRTs like Crossplane does, that API discovery transfer that the client does, it becomes extremely slow, and it'll do things like make all the operators that are running in your cluster effectively inoperable, or it'll make it very difficult for you to use kubectl, and it'll time out all the time and cause all sorts of annoying problems if you just install like everything in Crossplane at once. Eventually, Kubernetes will fix that, but it just hasn't happened from whatever we can see. And in Plural's case, a lot of what we do is we'll deploy a lot of different applications all in the same cluster for efficiency. And so if you deploy Crossplane alongside other applications that need operators and provision CRDs, it will really degrade the cluster pretty quickly. So that was one of the more like annoying things that we saw with it, and we sort of stopped using it as a result. But there are other solutions that do stuff for Crossplane specific to certain clouds. So like Google has Config Connector. There's other CRD cloud resource provisioners out there that can reduce the CRD scope and like keep your cluster from blowing up, basically.
Is it sort of plausible then if you have like a completely dedicated cluster just so you can use kind of like Crossplanes as cross cloud operators and just
you'll
nothing
mitigate
else.
the problem significantly. Or if you just use a single cloud provider for Crossplane and don't install like 3, it'll also mitigate the problem because it'll be less you'll create less CRDs basically. There's just like some number of CRDs at which your control plane will probably start having a lot of trouble.
So it's kind of like a cluster of clusters. Yeah, where the Crossplane is in. So yeah.
Yeah,
I think the
topology that people typically have with Crossplane is they'll have like a dedicated Crossplane management cluster, and it might manage other clusters, or it might just create resources and stuff like that. There's some other like interesting things you could talk about, like the user feedback dynamic around it, because if you're using Crossplane to provision resources, you're kind of hoping that your user is familiar enough, at least with kubectl, to be able to understand what's going on with the Crossplane resource, because they're going to have to like look at the CRD's status field to know if it was created successfully or it wasn't created successfully and all of that. And so, and what we frequently found is people just are not comfortable with kubectl at all, but they can sort of understand how to use the Terraform DSL. So what you guys are doing, where you're just using Crossplane as effectively a way to execute Terraform, makes a lot of sense from a user experience standpoint to me, because I think it's probably easier to actually teach people, or at least find people who already know Terraform, than it would be currently to get them to understand how the reconciliation of a Crossplane CRD is happening and how to debug that if they misconfigured it in some way. But that was another thing. In the worst case, if for whatever reason something is really weird, you end up having to actually go into the server logs for the Crossplane operator to like understand what's going on, which is a pretty unusual experience, and a lot of users will have some trouble with it. That said, like if you wanted to create a front end for provisioning resources, Crossplane is probably amazing for that, because you do have like wonderful little YAML objects that you can make API calls against and provision resources. Whereas, it's basically impossible with Terraform. You can't just dynamically generate Terraform code easily. But yeah.
Yeah, it was beginning to sound like Crossplane is like Rancher, just without the UI.
Yeah, that's basically its current status. I don't know if Upbound, which is the company that's trying to commercialize it, has created a decent UI. They actually might have. That probably is what they're primarily selling. So it might be worth like looking into that if you're interested in using Crossplane.
So how does Plural add the UI around all this and make it user-friendly for users that actually want a thing?
Yeah, so Plural is it's a different solution to the same problem. So what we're trying to do is we're trying to make it really easy for people to take an off-the-shelf software like Airflow, Airbyte, Dagster. Oftentimes our data software, but then there's also things like Grafana Mimir for metric storage, and deploy it into their own cloud. So you have an AWS account, you want an Airflow instance in it, or you want a Grafana instance in it. We want to make it as easy for you to get from that point A to point B. And what we have is a catalog of those open source applications that have been packaged for each of the clouds. And the packaging ultimately resolves to Helm charts and Terraform modules and a dependency tree amongst them. So if you wanted to deploy Airflow, it's going to have an Airflow Helm chart, an Airflow Terraform module, but then within it, there's going to need to be a dependency on a Postgres operator to provision its Postgres database, a dependency on the core Kubernetes runtime. That's things like external DNS, cert manager, ingress controller, stuff like that. And then Terraform ultimately actually provision the cluster from 0 to 1. So you can't run any of this without a Kubernetes cluster in the first place. And our command line tooling actually will generate a full Git repo for you that with those resources loaded into them. So you'll run Plural init, create a Git repository as part of the process. Plural build will generate all the Helm and Terraform for you, and Plural deploy will understand the dependency ordering of everything and then just execute it one by one to provision that resource.
That was kind of one of the things I found more impressive was just the onboarding, especially considering, and I want to highlight this because you kind of briefly mentioned it, but you can use Plural across different clouds almost like seamlessly.
Yeah.
Like if you set up on Google, well, okay, here are the apps you can use, and they have, I guess, this little like thin adapter for Google or AWS or Azure, and it just works.
Yeah.
Which brings me back to how Chalky was saying that, well, I mean, we did this thing in Rancher, but it almost kind of sounds like Plural would be cool for some of these additional bits and pieces.
There's also some other things. So we're giving you the ability to deploy Airflow, but we don't want to have as part of the trade-off you having to manage Kubernetes as a result of that. So like if the problem you're trying to solve is I don't know how to stand up and deploy Airflow, you probably can't also solve the problem I don't know how to stand up and deploy Kubernetes. So we make a few key decisions on that. One is we always use managed control planes because we don't want people to have the operational burden of understanding how to troubleshoot things like etc.d. And then we also have made a very good featureful UI for cluster administration. That's somewhat geared towards beginners, but in reality, I haven't found any Kubernetes use case that I couldn't solve with it. And it'll have things like interactive runbooks to be able to resize resources like databases within the cluster appropriately. It has it will actually accept and apply upgrades for all the applications for you over the air. You can add or remove users from OpenID Connect providers for the applications in that UI. And you can visualize cost information. Basically everything is a full like DevOps control plane for those applications we've rendered for you. And it's highly configurable as well. So we can tweak it in various different ways using CRDs to improve the operational experience. But the goal is sort of like you said, Rasmus, where like you really don't have to understand anything about Kubernetes at all. You just have to know that you want Airflow or Airbyte or any open source application, or theoretically the Atlassian products, and click a few buttons and run a few commands, and ultimately you actually have it deployed in your cloud if you have the permissions to actually provision those resources.
Cool. So yeah, that does seem like it lines up with what we've been using Rancher for internally, which is sort of like spinning up well-known applications in environments for use by individuals and so on.
Yeah.
And that's kind of like, that was our use case internally, because we needed demo environments for consultants to play with and do things and actually do work on the applications.
Yeah.
But that's also the challenge of developing applications in the first place.
Yeah.
So that gets into another interesting area of, okay, you have Kubernetes, maybe now you have it orchestrated to a point, then what? Because it's like there's some degree of we need some apps. All IT enterprises of different flavors need apps, but a lot of them are also developing their own things.
Yeah.
So that's where things like Backstage try to do like developer side things, but how do they meet in the middle? Like, are you trying to reach a point where you can also do like your own like homebrew stable of developed applications and deploy them, manage them across like environment tiers like dev, QA, production, that sort of thing?
Yeah. So the way we sort of like segment this is there's like two categories of applications. We can call one category third party or vendor software. Open source is in that flavor, but like the Atlassian products are another. So software that's actually developed by an organization that's not within your own purview, and you're bringing that software in-house to run. And then there's first-party applications, things that you would actually be developing and building for yourself or your own business. And that's actually the next thing that we're putting on our plate. We ultimately want it to be as easy an experience as possible to run anything you want on Kubernetes anywhere. That's kind of like going to be our overarching mission going forward. And being able to solve for first party would be the final step of that. And I think there's a few interesting things that I've seen pain points around here. So one obvious pain point is a lot of people just straight up do not know how to provision a Kubernetes cluster properly and understand its credential chain. So like it's actually non-trivially hard to create a Kubernetes cluster in Terraform. We've done it many times now, and there are lots of foot guns. So we're actually investing effort into using cluster API properly, because we think that's a better way of managing the lifecycle of Kubernetes long term. And the real big thing that happens is maybe you get the cluster up, but then the process of upgrading the cluster is just an incredible nightmare. And so we think that the upgrade flow within Cluster API and its constant reconciliation process is going to be a lot smoother than doing it with a lot of standard infrastructure as code. Another big pain point we've seen is the tool chain around authoring Kubernetes manifests is just not actually that great. Like Helm is cool, we use it, but if I were developing my own applications, I would prefer not to, honestly. So we're investing into like doing a really good job with CDK8s, which is it's a cool project that allows you to author Kubernetes resources in standard programming languages. JavaScript and TypeScript are the primary one, and that's a pretty good plastic language to do that sort of thing. But it also has support for Go and Java and some other languages as well. So we think having a good Kubernetes manifest authoring experience is a key portion to this. And then the other thing is actually being able to seamlessly deploy the applications is still a little bit tricky for people, especially because they don't know how to provision Kubernetes in the first place, and they don't know how to manage this credential chain and all of that. So the last thing would be building a proper deployment engine that allows you to take CDK resources from a Git repository anywhere and have a good staged pipeline deploy system from like dev to staging to production with like approval chains or integration tests in between and all of that. But we think like if you get all of those together and have them seamlessly interoperable, you have created what hopefully would be a pretty good developer environment around Kubernetes. And so that's what we're going to be focusing on.
Cool. All right.
Oh, you got no disagreements from me regarding Helm. I've actually been looking at CDKs as well for similar reasons.
Yeah.
And the same for Terraform and CloudFormation as well. Like their CDK equivalents are actually quite useful for you to avoid having loads of boilerplate or very odd ternary operations in code you just don't want. If you don't want that resource to exist, just omit it, please. When generally it has to be there, and you then have to resort to hacks to hide it.
Yeah, Helm is unavoidable now because it's gotten so big and so prevalent. So there's going to be just like Helm charts you're going to want to use. And fortunately, CDKs is compatible with it. You can inject a Helm chart into CDK8s. But there's like two things that we see that I've personally seen, having written a ton of Helm charts now. The template language kind of sucks. The Ghost template language is just very clunky and weird, and you can't do a lot of things you would ideally want. I've used other template languages before that were a lot better. Ghost is just not in that league. And the other big thing that bugs me is there's basically no good story for unit testing it. So ideally, I'd want the Kubernetes standard manifest I'd be writing to have a unit test associated with it that can run in CI when you have a pull request against it and validate that at least it looks sort of kind of good before sending it into a cluster. And that's a really tricky flow to actually do well with Helm. And I think it'd be very easy to do if you had something like JavaScript for your authoring language, because you could just use a standard JavaScript unit test framework, or similarly with Go, you could just use Go's unit test framework. So you could have a better like CI flow on the front end of your Kubernetes development, and then you could have your integration tests later down the pipeline. But it just like ties together a better life cycle around all of it.
That does sound like another missing piece of the orchestration, because I think like pre-Kubernetes, we were almost getting to the point of like doing better automated testing and really putting testing first and all those kind of things.
Yeah.
Then Kubernetes, have fun.
I don't know if it was easier. So, and the reason I say that is testing infrastructure is hard, right?
Yeah.
It's really, really hard, nigh on impossible. Like often the best endeavors you can do are actually compliance tests, at least ensuring that if you do deploy something in it and it works, it's not insecure. It's and like speaking specifically from a Terraform front or even a CloudFormation one. And actually, with Kubernetes, it's just shifted complexity on the most part. All you're trying to do is at least try and ensure some guarantees that it's going to deploy, rather than it integrating. If you see what I mean, because generally, when we deploy these things, we're bundling modules together that creates an end-to-end solution. Like no one writes one Terraform module for their stack. It's a collection of state files, and you're wiring them together to make something useful. And Kubernetes is largely the same, right? Or even down to the add-ons. That's another thing you're going to deploy. It's got to be configured correctly for the next thing you want to jump on there to deploy. So I don't necessarily see it as a solved problem. I don't think, because actually everyone's flavor of Kubernetes is different, and therefore tests will have to be different as well. Like you couldn't make an industry standard, here's a testing framework you can employ and it's going to work for everybody. Just like you can't take someone else's Helm chart and it just works on your cluster because you've configured it differently. So it's always going to be an ongoing problem. It's just the quality of the tools and making them, having them enable you is actually the important bit. And that's going back to the CDKs being important there, where you actually have you've got mature tools to actually do it with.
Mm-hmm.
Yeah, I'm intrigued now because, again, as a well-known dumb user, about the best I've done is get into Helm and like, wow, this is complex, and run into some of those templating issues. But, well, what if I want this environment to like look a little bit differently? And for a while, I got into like Customize and Helm running in different phases and all that kind of stuff. And it's just like, this just feels like it's getting worse. So whatever CDK is, save me.
I think like no matter what, you're ultimately going to have to be managing like a couple dozen plus objects, and the creation of them to use to like deploy a pretty significant service on Kubernetes is going to involve like probably a few deployments, a fair number of config maps, some services, some ingresses. But if the ideal is, creating a development flow around those objects that you can have fast feedback on whether you're screwing yourself up, basically. So like some testing it's the best I can think of. And then also just the Go templating language is just like not fit for purpose. So like if I were able to choose, I would choose not to use it. We use Helm specifically within Plural because it is just the industry standard tool. And so we don't want to inject, like, we want what we give people to deploy an Airflow cluster to be something that is as close to what they likely already know as possible. And it's also nice that I can just call it directly using the Helm SDK from our Go code. But for like a proper end-to-end Kubernetes development experience, I would use something else, and CDKs looks like the best solution at the moment. And there's a similar play. I don't know if you guys are familiar with Pulumi, but Pulumi has a similar like alternative to Terraform for standard cloud resources. So Pulumi, you can write the stacks in Pulumi in JavaScript or Go or all sorts of different standard programming languages, and it has a lot of advantages. So like for one thing, you can loop in it. You can have proper branching. There's like so much stuff that you can't really do well in Terraform that you can do in Pulumi, and it would just work because it's an actual programming language.
And another thing I want to ask them, because we talked a little bit about just like deploying applications off the shelf and potentially like developing and how do you do your own Kubernetes and so on. If you're in a large enterprise and you have bunches of different teams and so on, who kind of does what? Like, do we need to get into this newfangled platform engineering? And is that like one team that takes care of all the hard stuff, and then developers can kind of like, hey, it's a candy store, I will have some of that and some of that and some of these?
Yeah, I mean, that's an interesting question. So like I've seen this done in different ways. I've worked at like Amazon previously, Twitter previously, and a lot of different companies. And they have like, there have been like two different ways that I've seen the division of responsibilities flow. Like there's a lot of places that'll have consolidated platform teams. And then there's some places where like operations is a part of the standard like software development engineers' job responsibility. Amazon was actually the latter. So every engineer at Amazon had the expectation that they would do some degree of ops. And then places like Twitter or Facebook have been more in this, and actually Google as well, more in the veins of like a centralized platform team. I think if Kubernetes is done well, you should be able to have a very self-serviceable experience around provisioning new Kubernetes clusters and then creating deployment pipelines into those clusters in a way that is quite reproducible. And that's hopefully what we would be able to build. But that would move people more towards, I think, the Amazon model, which I thought was actually really, really good. Because like realistically, the knowledge of how an application is going to break is probably much more close to the developer of the application's head than a centralized team's head. But if your infrastructure is just too unwieldy for various reasons, you can't actually do that. Like you need someone who specializes in just like keeping the lights on. But if you have like the ability for an individual team or individual business unit to create a cluster for themselves, that cluster is going to be conformant based on various things, like maybe you put in your security scanning and all of that by default, and then they can just slap in their infrastructure, their Kubernetes resources defined in a consistent way. I feel like you could sort of reduce the need for that degree of like specialization around just keeping the lights on and managing the platform. But we're still definitely in the early phases, and it's ultimately kind of like the team's preference on how they decide to organize things. So it's like not actually a true right answer, from what I've seen.
Fair enough. I think we've also been going a little bit back and forth ourselves and like trying to think of new products and ideas and so on. Like Kubernetes orchestration. Is it like a Venn diagram when you have the Kubernetes orchestration circle, but then there's also some other stuff that's more like developer experience? Like how much do they overlap? Is there actually a sharp point where one ends and the other begins? Kubernetes is hard.
It's very complicated, yeah. But it's like it's a palette. It's like a white space. There's tons of things you can do with it, and you just have to like create the appropriate guide rails for your organization to use it use it in an effective way. From what I've seen, and some places do it really well. Lots of places don't. It's hard to say, but
I think all places have got to start with not doing it very well. I think that's actually the best place to start, because at least you've started. Is probably how I put it, and I think that's probably where we are as well as not that we're doing it wrong necessarily, but we're doing it the most right way we know how we can. Mm-hmm. If you see what I mean. And then you just got to keep iterating. You get the feedback, and then just keep adjusting and actually making the platform available for people to change as well. So I don't necessarily mean like you have everyone, the doors are open, people can just change anything they like, but I think that you shouldn't ever stop the customers internally from being able to like open a merge request to go actually like thinking of Crossplane as example. I've got a Terraform module I would actually like to expose. Could you wrap it for me, or could I just add it to a registry somewhere? You enable people to contribute towards it, because if you leave it up to a normal like a siloed team or a platform team, your customers will overwhelm you pretty quickly if they're not contributing.
Yeah. And that team oftentimes gets very quickly overwhelmed by like all the demands upon them. So they become a bottleneck and shed work, and it becomes inefficient as well.
Yeah, you would like to make the user experience, like I go back to user experience, right? You would like to make it where they can bring their own can bring their own templates, they can bring their own Helm if it's Helm, their own CRDs, and integrate it into the platform that they're building relatively easily. And then for the general masses to use it. So yeah, I think Rasmus' favorite word is eating your own dog food, right? So yeah.
Yep. I want us to go further with Kubera and Backstage and all these things, and just kind of figure out what does it mean to us, and is it meaningful enough to where we can think of a way of building products, because we have as Adaptavist. We've had so many clients over the years that are, using usually some large Atlassian suite, but a lot of them are also using all kinds of, DevOps tooling and things. And can we somehow distill something that we have figured out is doing well and put it into platforms somebody else can use?
Yeah,
that's where I find it interesting to think about, platforms like Plural and Backstage and others in trying to spot where are there areas that are still not really being served sufficiently by different actors. So that's where my interest comes in. It's kind of like I'm seeing Plural move into more like the first party developer stuff, and that's cool. That's great. I'm seeing Backstage like growing up a little bit and thinking about who uses Backstage. Is it like only developers, or would something like a PM or some sort of team lead ever be welcomed in there? Would they have something they could figure out and look at? Would they ever want to see something like Plural? Who is where is sort of my big question at times, but I'm not sure there's a clear answer on that quite yet. With that in mind, I have one other question that I'm just curious about. Kubernetes is great and all. It's also hard. We've ascertained that part. What about, enterprises that do things other than just Kubernetes, like serverless? Is there room for serverless in a platform that we might be able to think of Adaptavist or at Plural?
There has to be room for
very
it.
locked into Kubernetes.
There's a lot of love for Lambda internally at Adaptavist. The problem is there is actually anything like it either. And what I mean by that, there is obviously like other products that do serverless, but the developer experience that they've got is pretty solid, and it's well known, and they enjoy it. And to try and I wouldn't want to take that away from developers. I wouldn't want to say, oh, by the way, you can't use this anymore. And actually, what's nice is it's nice and atomic, right? They've got this one little repo, they've got this small bit of code, they're making a change, and that one change is live. And all the operational things they have to worry about, half of them are gone, right? Because that's what the whole point of using that sort of stuff is. And those are systems that still have limits, and then you still want to come and bring it back in-house. And actually, for some of our products, that's actually the case. Like, we do actually monitor that and go, actually, we now need to make this running this on a container or even on EC2 might actually be a better option. But you still have to make room for the serverless stuff, because it enables people to prototype really, really quickly. And they don't have to, and it enables small teams that aren't as cross-functional as they would like to be able to run something and not necessarily care about what they're running it on. They can just focus on literally the function itself. And they get and they get everything else for free. Even like scaling as just the first thing you can look at, right? You don't even have to think about it; it just happens. Okay, you introduce things like cold starts and stuff, but that's a very small part of the learning experience. And once you've got it, you're pretty good.
And that is the wonderful thing about serverless, is that level of simplicity. And I don't know if this says more about the industry or me just being a crazy nerd who finds all the challenges and things, but I feel like I've seen more out there how to use Kubernetes to enable serverless, like essentially your own Lambda replacement. Why you would ever do that is kind of like, I don't know. Then I've seen actual platforms and things that really aim to support serverless and make it easy, which it may already be sufficiently easy if you're just looking at Lambda on AWS. But would you ever see something like that in a thing like Backstage? It's like, you want to do serverless? Click this button, put some stuff in a Git repo.
You probably will eventually. You can now. It's just whether you want to make that jump. And so what I mean by it again is you already trust in Lambda. It already responds really, really quickly. You're relying on at that point, you're relying on AWS, you're relying on Amazon at that point, right? And the second you start doing it on Kubernetes, you're now relying on your one of your ops teams to do that. Can they scale as quickly, and can they do it as well? So it's a trust exercise to some degree and a maturity one. But it is doable. The case for it will be if your business cares about being multi-cloud or not, I think would be the bigger one. I mean, if you're a company that's already gone, you know, we drunk the Kool-Aid, we're with this provider, you might not want to. Obviously, we're having a chat about Kubernetes and I'm saying not to, but right tool, right job kind of thing. I think there might be high-level decisions to why you'd not want to do that. And there's obviously other reasons why you'd want to as well. Like, you want to be multi-cloud. So if I write this function once, and as long as I've got a cluster, it'll work, right? Or as long as I've got a cluster that's provisioned a certain way, it will work. When, if you're writing a function for AWS, or it's only run on AWS, you'd have to change it to run elsewhere, and that's the main benefit. I'm reluctant to say I don't think it would scale like AWS Lambda, because of course you probably could get it to. It's the endeavor that you're going to have to go through to make it do that. that I think is quite a steep, not steep. I think an expensive commitment is probably how I'd put it.
So that brings me to an interesting conundrum. Kubernetes is hard, but everybody's trying to do it. Serverless is kind of supposed to be easy, but I don't see it gaining that much traction or adoption, even having been out so long. So if Kubernetes is hard and everybody's trying to do it, but they're not kind of bad at it, and serverless is easy and some people are trying to do it, but it just isn't taking on, what's going on here? Are our problems as developers just like fundamentally so difficult that we can't figure the magic silver bullet that just does it right? Are we just gluttons for punishments?
We use service a lot at a previous company, and there's some interesting things that come out of it. So the lack of infrastructure is one of the benefits. The other real benefit is it effectively gives you scale to zero trivially. So if you have very bursty work, it's perfect. You actually save a ton of money. And we had like a service that would, the company was Frame.io, which is a video collaboration SaaS platform, but we had a service that ran Lambda functions on CloudFront, Lambda at Edge, that would resize videos on the fly and to just put them straight into CloudFront. It's like the perfect use case for serverless. The problem is, one, it gets really expensive. Like if you actually have consistent work going on, because you're effectively allowing Amazon to tax you per function invocation instead of like the amount of CPU that you're using consistently. So if you have something that uses a lot of functions, but it doesn't really use a lot of actual compute resources, they're going to just drain you. And the other weird thing is the developer experience actually can be kind of weird. So you really can't run a Lambda function without putting it into Amazon, for instance. Whereas with the Kubernetes development flow, you can always just run things in Docker Compose, and that's going to be effectively equivalent to it running in Kubernetes. Like that's not entirely true, of course, but it's true enough. So like what we found is our developers were much more productive in just a bog standard Docker-based workflow than the serverless workflow, because like for them to actually get the full like serverless experience, they would have to be toggling between like 10 or so different serverless functions that all orchestrate with each other, but they don't actually really work locally. So you had to deploy it into the cloud, but then you have to go through approvals to deploy into the cloud. And it's just like it became a real pain in the butt. So I think if you like have like that perfect use case for it, it's really, really cool. Another thing is like AWS has like serverless Aurora databases now. So if you have like a dev database, you can make a serverless. It'll scale to zero on off hours when you have no developers up and actually using dev. But there's a lot of use cases where it's still not exactly fit for purpose. And then like the Kubernetes serverless experiments, like there's Knative out there. I think there are probably a few others. They are pretty good, so they can solve the cost problem, obviously, because it's just going to be running in your Kubernetes cluster. But then you have the problem of it not necessarily giving you scale to zero, because it's got to still have the Kubernetes cluster underneath it. So you kind of have like a $200 minimum to run the serverless on that individual Kubernetes cluster, and that might actually kind of be more expensive than you were expecting to run that service. So like the gap is just still like a little bit awkward. But if you had a very large cluster and you could throw Knative on it, you for sure could probably outperform on a cost perspective, Lambda function or Google Cloud Run or any of the other competitors.
It almost feels like these cloud providers just want to make money off or something.
Well, they are businesses. So I was saying about scaling, your point was much more clear. Like you can scale to zero. That's the point. You don't have resources just sitting there costing you money when they're not actually being utilized. But if they are being utilized heavily, you're just spending extra money, essentially.
A lot of extra money. And you aren't necessarily getting a better development workflow out of it as well, which is kind of like, if the development workflow is just utterly beautiful, then maybe you spend that money and you claw it back with like having less engineers. But that's not actually true. At least it wasn't true at the time when we were using serverless. Maybe it's gotten a lot better. But the stuff that's like we've seen be really, really cool is the edge serverless stuff, like Lambda at Edge. I think CloudFront has Workers now, which is effectively a serverless offering as well. So there's a lot of compute that you can do in the edge, like resizing images or video and stuff like that. That can then be quickly cached, and there's probably a lot of play for how to use serverless in those and those capacities.
Those would be good in front of a Kubernetes cluster as well, to be fair.
Yeah.
Used in conjunction rather than, we're almost having a conversation as if one's better than the other, but actually they're very complementary.
Especially they both work together. Yeah.
I think I'm going to go with Kubernetes is hard, and so is development. But there's a lot of cool, toys and tools out there for us to play with, and maybe that's enough to keep your career interesting and exciting.
Yep.
And with that, I think we're about ready to wrap up. So thank you so much for coming, all of you. Michael, Tim, Chalky. I hope to talk to you all again soon.
Thank you very much for having us.
Thanks for having me as well.
Catch you later, Pete.
Thanks for joining us to discuss Kubernetes and lots of other interesting tools today. This has been DevOps Decrypted, which is a podcast on the Adaptavist Live network. Please contact us on social media to let us know how you're finding the show. And thanks for joining us. Thanks, everybody.